Hello and welcome to this video. In this video, we are going to see about asymptotic notation in Python. Let's see what is asymptotic notation. Asymptotic notation is a way to describe the behavior of a function as its input size approaches infinity. It helps us understand how an algorithm or data structure performs as the input size grows. We have three types of notations. They are big O notation, omega notation and then theta notation. Big O notation. It describes the upper bound or worst case scenario of an algorithm's running time. It represents the maximum number of operations an algorithm performs for a given input size. The time complexity of this function is O of n as it iterates through the array once to find the maximum element. Here is the example of big O notation. In this example, findMax function is used, which is designed to find the maximum element in a given list array. The first line defines the function name findMax that takes one parameter array which is expected to be a list. Next line is for initialization. It initializes the variable max element with the first element of the input list array. This assumes the list is not empty. Then we have loop, for loop. This initiates a loop that iterates through each element in the list array. If element is greater than maximum element, it checks if the current element being iterated is greater than the current maximum element. If the current element is greater than max element, it updates the max element to the value of the current element. After iterating through all elements in the function, returns the max element which holds the maximum value found in the list. Next, omega notation. Omega notation describes the lower bound or the best case scenario of an algorithm's running time. It represents the minimum number of operations an algorithm performs for a given input size. The best case time complexity of this function is omega 1, as the number may be found in the first iteration. Next, we have example of omega notation. This code defines a function called isNumberInList that takes two arguments, number and sorted list. It is intended to check if a given number is in the sorted list. In the first line, isNumberInList function is defined. And then iterating through the list. The function iterates through each element in the sorted list using a for loop and then checking the elements. For each element in the sorted list, the function checks if it is equal to the number that is we are searching for. If the element is equal to number, the function immediately returns true, indicating that the number is found in the sorted list. If the element is greater than number, the function immediately returns false, indicating that the number is not present in the sorted list. Since it is a sorted list and if element is greater than, the number won't be found later in the list. Then default return. If the loop completes without finding the number, the function returns false, indicating that the number is not in the sorted list. The function efficiently checks if a number is present in a sorted list by iterating through the list and comparing each element to the number. It takes advantage of the fact that the list is sorted to return false immediately if it is encountered an element greater than the number. This function is a simple example of how to search for a number in a sorted list and showcases how you can use control flow in Python function to efficiently handle different classes. Next, theta notation. Theta notation describes the tight bound or average case scenario of an algorithm's running time. It represents the average number of operations of an algorithm performs for a given input size. The time complexity of this function is theta of n, as it performs a constant number of operations for each element in the input. Next, here is the example of theta notation. The function used here is sum first n numbers. First line have a function named sum first n numbers. Then we have a return statements with the expression using a formula n into n plus 1 the whole divided by 2. It calculates the sum of the first n numbers if we were to include 0 as the first number. This sum is twice the sum of the actual numbers we want to sum. Then dividing this sum by 2 gives us the correct sum of first n natural numbers. The asymptotic notation provides a standardized way to analyze the efficiency of algorithms and data structures. By understanding big O, omega and theta notations, we can make informed decisions when designing and implementing algorithms. This is about asymptotic notation. Thank you.